Hello. In this video, I'm going to talk about applying truth tables to evaluating arguments and argument validity now that we've understood how to use truth tables for individual sentences. So let's start by looking at two arguments to remind ourselves about what argument validity is. So here's an argument. If Bob eats cookie, Bob is happy. If Bob is happy, Bob smiles. Therefore, if Bob eats cookie, Bob smiles. This is a valid argument. What does that mean? Well, more or less, it means that the conclusion is true if the premises are true, no matter what. In any situation in which the premises are true, the conclusion is also true. And we could demonstrate that in different ways. We might do it by producing a derivation, or we might do it by doing a truth table, and that's what we'll be talking about in this video. Now here's another argument. If Bob eats a cookie, Bob is happy. Bob eats a cookie or Bob eats broccoli, therefore Bob is happy. This argument is invalid. How might we show that? Well, consider the following situation. Let's say Bob eats broccoli. That makes the second premise true. Let's say that Bob doesn't eat a cookie and Bob isn't happy. That means the first premise, the conditional, is true. But if Bob isn't happy, then the conclusion is false. So both the premises are true and the conclusion is false, and so what we have is a counterexample with true premises and a false conclusion. So what does it mean to say an argument is valid? It means that the conclusion is true in every situation in which the premises are true. And another way of saying that is that there's no situation in which all the premises are true and yet the conclusion is false. There's no counterexample. We'll be talking occasionally, and in the truth table module, the module will use the word tautologically valid instead of valid. Just don't worry about that, what that tautologically is doing there, and we don't need to worry about that for our purposes. Okay, so another way we can say that an argument is valid is we can say the conclusion is true on every row on which the premises are true. Now talking about truth tables, and we can say there is no row on which all of the premises are true and the conclusion is false. So those are two different ways of saying the same thing, and what we can think about that, one way to think about that is there are no counterexample rows. So that's what it is for an argument to be valid. Of course, if it's invalid, then there will be a counterexample row like we saw with that initial example. And to be clear about that, let's just look at a simple example. This isn't the whole truth table for an argument, but let's suppose that we knew that not P was false, and if P then R was false, so we had the true premises, and we also knew that the conclusion, not R, was true. Would this be a counterexample? No, because the conclusion is true. Okay, well, let's consider another row in another situation. In this situation, the first premise, not P, is false. The second premise, if P then R, is true. And the conclusion is false. Now ask yourself, is this a counterexample row? Really, what do you think? Well, what does it have to be like to be a counterexample row? Well, the conclusion has to be false, and on this row, the conclusion is false. But also, both the premises need to be true for the row to be a counterexample row. And on this row, the first premise is false, and that means that this is not a counterexample row because it's not a situation where all the premises are true. Okay, let's consider another row. So we have a true premise and a false conclusion. So do you think this is a counterexample row? Well, for a counterexample row, you need a false conclusion, and we have a false conclusion. And you need two true premises, and we do have true premises. And that's all you need, so this is a counterexample row. So that's what a counterexample row looks like. True premises, false conclusion. So this argument, in fact, is invalid. And now just to be clear, this is not a complete truth table for two reasons. First, it only has 3 rows, whereas if it was a complete truth table row, it should have 4 rows because there are 2 sentence letters, P and R. But also, it doesn't even have the truth values for P and R, so this is a completely incomplete truth table. But that's okay, it makes the point about what a counterexample row is. Okay, so that's our example of a counterexample row. How are we going to use this more generally to tackle argument analysis using truth tables? So we want to be clear, it turns again on counterexamples. A counterexample to validity, true premises, false conclusion. So that means a bad row is one that has a false conclusion and all the premises are true. So, okay, fine. What about okay rows, not bad rows? Well, if a row has a false premise, then it's not a bad row, it's not a counterexample to validity, and so it's an okay row. And if a row has a true conclusion, then it's not a counterexample to validity, and so it's not a bad row, so it's an okay row. So there are two ways for a row to be okay. Either it has a false premise or a true conclusion. So these notions of bad row and okay row, that's the way we're going to be thinking about rows when we evaluate arguments for validity using truth tables. Is the row bad, meaning that the conclusion is false and all the premises are true, or is the row okay, meaning either that there's at least one false premise or the conclusion is true. So if an argument has at least one bad row, then it has a counterexample and it's invalid. On the other hand, if all of the its rows are okay, then there are no counterexamples, and so the argument is valid. So we're thinking either at least one bad row, invalid, or all okay, valid. So that's the dividing line. Either there's a counterexample or there isn't. Either there's a bad row or all the rows are okay. If there's a bad row, invalid. If all the rows are okay, valid. Okay, so that means that's the way in which we're going to be thinking. Either we're going to find a bad row, or we're going to find that all the rows are okay. And we do one of those two things, and that's how we figure out that the argument is either invalid or valid. So how do you do this? You start by looking at rows, and if you find a row with true premises and a false conclusion, the row is bad, the argument is invalid, and you're done. On the other hand, if you find a row with at least one false premise or a true conclusion, the row is okay, and you go to the next row. If you keep doing that and you find that all the rows are okay, then the argument is valid and you're done. So one of those two things is going to happen. Either you'll eventually find a bad row, or all the rows will have turned out to be okay, and either way you'll have decided that the argument is invalid or valid. So just to be clear about this, and what's our method? Well, you pick a row, whichever one you like, and you're going to determine, is it okay, meaning that it has a true conclusion or at least one false premise, or it's a bad row, meaning that all the premises are true and it's a false conclusion. If the row is bad, the argument is invalid, you're done. If the row is okay, go to the next row. If all the rows are okay, the argument is valid. And just to be clear about checking for okayness, once you find a false premise or a true conclusion, you're done with the row. You don't need to determine all the truth values on the row. Once you know it has at least one false premise or a true conclusion, you know it's not a counterexample row. You don't care about the rest of the truth values on the row. So this is what a completed, if you did the whole truth table for this argument we were looking at earlier, this is what it would look like. On the left-hand side, there we have the two sentence letters, the P's and R's, and the four combinations, the four rows of the different possible truth values for P and R. And then I've assigned all the truth values for not P, and if P, then R, and not R. And lines 1, 2, and 4 are all okay, because on line 1 we have a false premise, and there's just one false premise. On line 2 we have two false premises and a true conclusion, and on line 4 we have a false conclusion. But on line 3, so lines 1, 2, and 4 are okay, but on line 3 we have true premise, false conclusion. That's a bad row. That makes this argument invalid. Now, when we look here, so there are the sentence letters, there are the premises, and there's the conclusion. We want to be clear that what's immediately relevant to the argument's validity, what figures in the definition of validity, are the truth values on the right, the truth values of the premises and the conclusion. And those truth values are what make a row bad or okay. The truth values on the left here, these are the truth values assigned to the sentence letters. The sentence letters are not premises. They're just a description of the situation of the world, and then we ask, are the premises and conclusion true if the world is the way if the world is that way, makes those sentence letters have those truth values. So they don't by themselves make a row bad or okay. They just determine the truth values for the premises and the conclusion, and then it's the truth values of the premises and the conclusion that either make the row bad or make the row okay. So that's the sort of conceptual approach to working with truth tables for arguments and validity. I'm going to do another video in which I actually do some examples, so you'll see how it's done.